Hello, and welcome to the next installment of the quarterly webinar on Parkinson's disease, brought to you by Cure Parkinson's, the Journal of Parkinson's Disease, and the University of Edinburgh. My name is Thilo Kunath, and I am sitting in the Centre for Regenerative Medicine in Edinburgh, Scotland. So welcome everyone from all over the world. So today we will be discussing a very exciting topic, the gut-brain axis, nutrition in Parkinson's, and the microbiome. But just before I introduce the panel, I wanted to mention that we welcome lots of questions from you. So post your questions in the Q&A. We will get to them at about halfway through. A lot of the questions will be handled by Dr. Simon Scott, who is a director of research at Cure Parkinson's, also the brainchild behind the website, The Science of Parkinson's, where he explains Parkinson's research in accessible English, plain English. So he'll be answering some of the questions, and we'll answer some on our side. So I'm going to introduce the panelists very briefly, but today we have Professor Pierre Borghammer from Aarhus University, Professor Kieran Toohey from University of Leeds, Rochelle Flanagan, registered dietitian from Ireland, and Rick Lay, a Parkinson's advocate. So Rick, can you introduce yourself, please?
Sure, thanks, Thilo. Hi, everybody. I'm Rick Lay, and I'm going to start by saying I'm incredibly humbled to be asked to join this panel today, a panel of immense experts. I, on the other hand, am not an expert. I have Parkinson's. I've had Parkinson's for 7 years, and during that time I've been really active in helping myself, very much focused on exercise, taking part in research, and obviously the diet as well. But today my role is very simply to learn. I'm sure there's going to be a lot of learning on my part. I'm going to be jumping in if there's any of our fantastic panelists get overly excited with the science and get too technical. And also I'll be sharing experiences, but only when relevant as well. So welcome everybody. I think we're in for a great session.
Great. Thanks. Pierre?
Thanks, Thilo. So my name is Pierre Borghammer. I'm a nuclear medicine specialist and a Parkinson researcher for the last 20 years. I'm situated in Aarhus, Denmark, and do research in human imaging of patients and animal models and study brain tissue and a lot of other things. I'm very happy to be here. Thank you.
Great. Welcome. Rochelle?
Hi, I'm Rochelle Flanagan. I am a registered dietitian with 20 years experience based in Dublin, Ireland, and I have lived with young onset Parkinson's for the last almost 7 years. And a big passion of mine is the realization that there's a lot more that can be done to help people with Parkinson's through diet and nutrition, and there's a lot of research that still needs to be done. So happy to be part of the discussion today. Thanks.
Brilliant. Perfect. Kieran, please.
Hi, I'm Kieran Toohey. I'm a microbiologist working in the School of Food Science and Nutrition at the University of Leeds. I'm quite new to the Parkinson's field, and I'm coming at it from a slightly different angle, looking at how diet changes the gut microbiota, because we know both diet and microbiota changes in Parkinson's disease. So I'm happy to take questions around that field.
Great. Let's start with you, Kieran, just to get us all at the the beginning. So what is the gut microbiome? How is it involved in health and disease, and specifically in Parkinson's?
Okay. Well, the gut microbiome is the name we give to the collection of microorganisms, and that would be bacteria, viruses, fungi, protozoa that inhabit our intestinal tract. Now, where are they? The vast majority are in the colon, or the large bowel. And then we have smaller numbers or smaller population sizes in the small intestine. Now, because the small intestine is quite difficult to access, we know much more about the large bowel microbiome than the small bowel microbiome. And that's causing some problems when we realize that most of the absorption and the immune function is centered around the small intestine rather than the large intestine. However, we do know that our gut microbiome responds very rapidly to diet, and it changes the way we metabolize our diet. So, for example, It can change the metabolites that we derive from amino acids and proteins, play a role in the gut-brain axis that we'll talk about a little bit later on, and vitamin K. But probably the most important function is to take dietary fiber. So in its broadest sense, in terms of any carbohydrate that escapes digestion in the stomach and small intestine, to take that fiber and carbohydrates and turn us into what we call short-chain fatty acids, things like butyrate and acetate. Acetate is another word for vinegar. And these metabolites regulate very important processes in our body. First of all, it regulates the permeability of our gut wall. So it regulates whether we have a leaky gut or not. And that's related to inflammation, both in the intestine and then all around the body as well. These metabolites also regulate the function of immune cells, whether they have an inflammatory response or, importantly, whether they can switch off inflammation. Now, inflammation is very important because it's our first line of defense against bacteria and viruses. So we need them to kill these harmful microorganisms. But when we can't turn it off, that inflammation then causes damage. And there's a lot of work Pierre will talk about a bit later on about inflammation in the brain and its role in Parkinson's. So for me, that interaction between fiber and short-chain fatty acids is probably the main function of the microbiome.
That was excellent. Excellent. Thank you.
Okay.
Thank you very much. Actually, I'm going to go to Pierre to explain two things. So first one, what is the gut-brain axis? If that you can address that first. And then I'm really keen to hear about a lot of the recent work or a large body of work on brain first versus gut first Parkinson's. So if you could address those two questions, simply what is the gut-brain axis first, and then this model of Parkinson's that you've been championing.
Yeah, thank you very much, Thilo. I'll be happy to. So first, your first question, what is the gut-brain axis? We have a brain and we have a gut. And there's a lot of crosstalk between the brain and the gut both through nerves. So the brain and the spinal cord, you could say, sends a lot of nerves to the gut. And inside the gut, we actually have what we call the third brain. There's maybe 500 million nerve cells embedded in the gut, which is responsible for contracting the gut, so peristalsis and these things, and secreting mucus and all sorts of other things. So there's a crosstalk using nerves, but moreover, there's actually also the gut and the brain speak to each other via the bloodstream, via hormones and proteins, and that are being sensed both by the gut and by the brain. And so they can continuously, both organs know what the other organ is doing, so to speak. So that's kind of what we call in a nutshell the gut-brain axis, and that's could be particularly interesting and important in Parkinson's disease for several reasons that we'll be discussing. So do you think that covered it, Thilo? Okay, good. Okay, so Thilo asked me to just very briefly explain about this idea of gut first, or also called body first Parkinson's disease on the one hand, and brain first Parkinson's disease on the other hand. That's an idea that we have, I guess, been particularly interested in promoting the last few years, because we think there's a lot of evidence for it. So if I start by body first disease or gut first disease, what is that? Well, we think that the disease simply starts by in the sense that small proteins called alpha-synuclein, proteins in the gut, in the nerves of the gut, starts to clump together. That's what we call aggregates. Okay, so so the disease starts in the nerves in the gut. Then it spreads because these clumps of protein can actually multiply themselves inside the neurons. And since there's nerves coming from the brain down to the gut and from the spinal cord to the gut, this protein spreading mechanism can work its way backwards and into the spinal cord and the brain. Okay, when it reaches the bottom of the brain, the bottom of the brainstem, as we say, just below your ears, it's actually inside the brain, and then it can move up and up and up over the years. So that is in essence how body first disease starts. If we look at the symptoms, this kind of fits with that some patients develop problems with constipation many years before diagnosis because the gut is sick many years before diagnosis. They can develop urinary problems before diagnosis. They also often develop a particular sleep disorder called REM sleep behavior disorder before diagnosis. That's the disorder where you live out your dreams, you shout while you sleep or flail with your arms. That can come many years before diagnosis. Why? Because the sleep network, so to speak, in this sense, is quite low in the brain. It's below the dopamine system. So it gets affected before the dopamine system. And that's why the symptom appears before diagnosis. Then eventually, the top of the brainstem is affected. That's where the dopamine cells are situated. And once some of those have undergone damage, the patient will start to experience the classical motor symptoms that we all know, perhaps go to a neurologist and get the diagnosis of Parkinson's disease. So that is the evolution of the symptoms and the pathology. If we look at tissue from dead patients that have donated their brain and tissue so it could be studied, we can see that perhaps up to 50% of people that had Parkinson pathology in the body, in the nerves, about 50% it's very compatible with there's most pathology in the body, or you could say at least in the bottom of the brain, in those nuclei, in those clumps of nerve cells that speak to the gut. So it really suggests that the pathology came from there. And another point is that when we do imaging studies like brain scans and gut scans and heart scans of living patients, if we examine early patients, we can see that the body first patients have quite a lot of damage on these scans to the heart, to the gut. But if we get them early enough, the dopamine system is still normal, but the heart is not normal. So that shows you that the damage to the heart started many years before the dopamine system is affected. So that's body first. And then I can quickly say the counterpart is what we say brain first, but perhaps we should call it nose first in many cases. We think the fundamental idea is very much the same. The disease starts outside the brain. It starts in the nose epithelium. That's what we call it, kind of the skin you have inside your nose. Perhaps because of infection or something, we can discuss that. But then the pathology can start in the nerves that you smell with, the olfactory nerves. That's what we use to smell with. And then the pathology works, and it's the same kind of protein material. It works its way backwards to some other structures that's closely connected to the nose. And those structures are closely connected to the dopamine system. So actually, nose first or brain first Parkinson's, we think that pathology travels to the dopamine system faster. Again, once some of the neurons, the dopamine nerve cells have undergone damage, the patient gets the Parkinson symptoms, gets the diagnosis. But at that time, the patient does not have constipation or urinary problems or sleep problems because all of those structures are below the dopamine system when the pathology comes from upstairs, if you will. Eventually, some of these patients over the years can actually develop the sleep problem and constipation and these things, but in brain first, it comes after the diagnosis because the pathology is going down whereas in body first, the pathology is going up, so everything is in the opposite order. So, and again, if we look at imaging studies, we can see early brain first patients have an affected dopamine system. Everything else below is more or less normal. And if we look at tissue from dead patients, we can see that up to half of the patients have most of the pathology kind of up in the brain and not a lot of pathology in the spinal cord, or perhaps none at all, or in the peripheral organs. So that also suggests that that supports that there are these two overall types when we look at both imaging and the symptoms and tissue from deceased patients. I think that's a very brief summary of the idea.
That was excellent, Pierre. That was really clear. This nose first versus gut first model is yeah, I think is really informative. And I think today we'll be speaking a lot about gut first because we're going to focus on the gut microbiome. But I'm sure there is a nose microbiome as well that may be impactful, but we don't know as much about the nose microbiome. But we'll move to Rochelle first. I think this question is for everyone. So Rochelle, how does nutrition or diet, I guess, affect the gut microbiome? And what do we know about the differences between the gut microbiome in people with Parkinson's versus people without? So maybe that's a question for everyone, but we'll start with you, Rochelle.
Yeah, it's a big question. I suppose in terms of the second part, what is the difference between someone with Parkinson's, their microbiome, and someone who doesn't? And certainly from the research I've seen, that people with Parkinson's have more of a dysbiosis, or an overgrowth of different type of bacteria in the bowel. But two particular bacteria that keep coming up are bifidobacteria and lactobacilli, which are always prevalent. And some of the kind of healthier bacteria seem to be less in the bowel. So there's a different, I think they call it like signature of your bacteria in someone with Parkinson's versus someone without. And I suppose what I find kind of fascinating about the bifidobacteria and lactobacillus being high is they're normally anti-inflammatory bacteria in the bowel. So there's a kind of question as to why are they raised in people with Parkinson's? Have they gone to the dark side? Have they become basically pro-inflammatory? Or is it that the body is actually sort of trying to create these anti-inflammatory bacteria to create more of them to try and counter the inflammation in the body? So we're not too sure what the answers are there. And I suppose in terms of from a diet point of view for Parkinson's, it's shown that, back to Kieran's point with regard to fiber being really important for health in general, by producing, helping, it's the fiber is kind of like a food to produce these short chain fatty acids, and a thing called butyrate, which are important for cancer prevention, but it seems to be also potentially in Parkinson's, that it plays a role as well in prevention, because we know that diets that are high in fiber are linked to a lower risk of developing Parkinson's. So in terms of the microbiome, the question is, what is creating this extra lactobacillus and bifidobacteria? And I know, Kieran, you had made a point with regard to that when we had a discussion before, that perhaps it is the fiber, the bacteria feeding on the fiber, that's creating that. I don't know whether you'd like to comment on that.
Yeah, I think that's a key discussion here, how diet changes microbiome in Parkinson's. Take the bifidobacteria, for example. Traditionally, we'd see these as very beneficial bacteria. They're the bacteria that are stimulated by breastfeeding, for example. So we see them as a natural partner in our bodies. But they do respond very quickly to changes in carbohydrate intake. So if you take people who are overweight and you put them on a low carbohydrate diet, bifidobacteria decrease really rapidly. So they respond to carbohydrate changes. They colonize the end of the small intestine and the beginning of the large intestine. So changes in sugars in particular could have a potential to really cause a bloom in bifidobacteria that would be more of a signal of the dietary change rather than any disease mechanism. Now, interestingly, we know that Parkinson's disease is associated with very high sugar intake. And I'd really like to see, I haven't seen any data yet, but it'd be very interesting to look at how that diet then impacts on bifidobacterial populations. Normally, in human studies, we're trying to reduce sugar intake, but it might be a nice experiment to see what happens when we put somebody on a high sugar intake through the bifidobacteria. In terms of the butyrate production, one of the characteristics of gut dysbiosis in general, but also particularly in PD, is a reduction in the butyrate producing bacteria. So they're reduced mainly or a change in abundance in response to dietary fiber. So I think that there's a big story there around quality of the carbohydrates in the diet, both in terms of risk of Parkinson's, but also in terms of how it regulates the microbiota and how it determines butyrate production. And as you said, butyrate is a very important molecule, especially in the gut, because it regulates not just immune function, but the tight junctions between these cells on the gut wall. So the immune cell, the skin cells, the epithelial cells in the gut are like bricks in a wall. They're tied together like this with proteins. If you have very little butyrate, these cells start to become more separated and you get gaps between them. And that allows things that shouldn't cross the gut wall to get into the blood system where they can cause inflammation. Whereas if you have high butyrate, these cells are bound very tightly together by these proteins, and that stops the absorption or translocation of these inflammatory molecules from intestine. Now we know some proteins, some metabolites produced by the gut microbiota can also mimic the alpha-synuclein that Pierre was talking about. So they can actually be a triggering agent for the initial plaque formation. So I think there's several possibilities around linking microbiota and their interaction with diet through a leaky gut and the occurrence of these molecular mimics of synuclein, alpha-synuclein, can play a role in causing or triggering the disease in the first place.
Sorry, go on, Rochelle.
I was just going to come in on that in terms of the leaky gut. I think that's, something that really needs more investigation. I mean, in terms of, there's talk of things called endotoxins. So basically that are produced by the bacteria that can kind of get through that leaky gut and into the bloodstream, for example, and create, I think it's called liposaccharides is the term for it. And I suppose also, I noticed someone had asked the question about celiac disease. To date, there's not a huge link between celiac and Parkinson's. So interesting, there was a study out of Sweden just published there recently that showed that people with celiac under the age of 60 had a more likelihood of developing Parkinson's within the 5 years after diagnosis. And leaky gut is associated with celiac disease. And we also know in terms of inflammatory bowel disease like Crohn's and colitis, that people who have inflammatory bowel disease have a higher risk of Parkinson's, but when they're on the anti-inflammatory medication, that risk sort of fades away. So, and also there's the leaky gut, in inflammatory bowel disease as well. So I suppose, maybe it sounds like we should really be looking. And just the other question is about glucose metabolism. So, diabetes has people with diabetes have a higher risk of developing Parkinson's too. And also it's an autoimmune condition. So Crohn's and colitis ulcerative colitis are autoimmune, celiac is autoimmune, and diabetes is autoimmune. So, there's definitely some kind of trend going there with regard to the inflammatory. So I don't know if anyone else wants to chime in on that.
I was going to ask Rick for his reflections so far. What are you thinking so far, Rick, and what you're hearing?
I mean, there's a lot of fantastic insight that's been shared by the panel. From my perspective, when I'm hearing presentations like this, I'm often coming to the same question, which is very simply, what does this mean to me right now? What can I be doing right now? I think that's something that people on the call would appreciate hearing, because of course people are aware that they should be thinking about their diet, but I think perhaps not necessarily clear on the nuances of quite what. One of the quotes that sticks in my mind about food is from Michael Pollan: "Eat food, not too much, and mostly plants." That sounds like a great starting point for everybody. But what should we be doing based on the insight that you've shared already? Because we have Parkinson's, that might be of interest to people.
I might, I suppose, answer that in terms of the practical. So the research would show that the kind of most beneficial diet at the moment, what's ahead of the game, is the Mediterranean style diet. And interesting enough, obviously that diet is very high in plant foods, so fruit and vegetables, which are high in fiber and different types of fiber, which really help to nourish the gut. But also they contain other foods like pulses, like chickpeas, kidney beans, those kind of foods. And also, if you think of sort of Mediterranean style diet, or, in France or Spain, a lot of the cooking is based on onion and garlic, in terms of as a base for cooking. And these all contain what we call prebiotic fibers, which are basically fibers that, are kind of food for the bacteria in the gut. So are very beneficial as well. So from a very practical point of view, it is that Mediterranean style diet. And then other constituents of the Mediterranean style diet are things like olive oil, which is kind of an anti-inflammatory, part to it. Also in terms of olives, and also in terms of the fruits and vegetables, they have, phytonutrients that basically are anti-inflammatory as well. So that's really important. But I think the other thing to take into account is the individual nature. So constipation is a huge problem for people with Parkinson's. So obviously the fiber, in terms of Mediterranean diet as well, getting whole grain foods into the diet help to move the constipation, move the bowel, which is really important, because when you're constipated, that sort of creates kind of a more of a feeding ground for the bacteria. Also means that your medication may not be as well absorbed as well. But also there's other things. So some people suffer from a thing called gastroparesis, which is slow stomach emptying. And that brings its own problem, because if you have a lot of fiber when you have slow stomach emptying, it's actually going to slow it even more. And that's going to cause people a lot of symptoms of gastroparesis are, feeling full very quickly after meals, nausea, losing your appetite, losing weight. So, someone then following a high fiber diet, that's not going to be beneficial. It's going to actually worsen things for them. So it's a bit like they say, you see a person with Parkinson's, you see a person with Parkinson's, one person, it's very individual. And I suppose the other things to take into account are, I saw in some of the questions there with regard to PPIs. So we know that, and some of the panel here might speak to this, but people with Helicobacteria have a higher risk of, Helicobacter pylori bacteria have a higher risk of Parkinson's. But interestingly enough, people who are put on, proton pump inhibitors for reflux, etc., have a higher risk of small intestinal bowel overgrowth, which is associated with basically, an overgrowth of less healthy bacteria, which tends to eat your levodopa, which can cause problems in terms of your symptom fluctuations. So there's so many parts of this puzzle that need teasing out on an individual basis. So I'll leave it there in terms of if anyone else wants to.
No, that was excellent. So it is incredibly complex, but the amount of questions coming in are a lot. So I think I want to transition to answering questions for the last half hour. Simon is doing a champion job of answering some of them, but he's left a number of us for us. So I'm just going to pull out a few of them as we're going on. So this is a simple one. No, a simple one. This is one for Pierre. Is the rate of progression faster, or is there a difference in rate of progression between nose first or gut first Parkinson's?
Thank you, Tilo, and thank you to the questionnaire for that question. It's actually not a simple question at all. It's very complicated to answer. There's some evidence to suggest that the body first disease has a somewhat faster progression. So that means some additional non-motor symptoms will appear faster, and perhaps also the motor symptoms can progress a little bit faster. Okay, but what does that mean? And that's where the complicated part comes in. What I just said is only valid if you kind of start the clock at the day you get the diagnosis. So, and because we start the clock based on the dopamine system, because the dopamine system, the damage is what gives you the symptoms, and then you get the diagnosis. However, if we think about, okay, but what happened the many years before we get the patient gets the diagnosis? And that's the point, because there's lots, in my opinion, lots of evidence to suggest that the prodromal phase, that means the years before the diagnosis, that's a longer period in body first disease. So put it another way, it actually means that body first patients are being diagnosed at a later time point compared to brain first. So in that sense, it's perhaps not so strange that the progression is perhaps a little bit faster, because the disease is a little bit more advanced at that stage. So that's the complicated answer. I hope that was helpful.
It does make sense. It does make sense. Yeah, thank you. Kieran, I'm going to ask you another audience question. Butyrate is produced in copious amounts in the ketogenic diet. Would you or Rochelle recommend a ketogenic diet for Parkinson's?
Well, I think there's a lot of common molecular overlap between beta-hydroxybutyrate and butyrate produced in the gut. So they're both molecules that can really communicate between the gut microbiota and the energy warehouses of human cells called mitochondria. Now, mitochondria back in the day, going back to evolution, were actually bacteria. So it's not that strange that they respond to the same molecules that bacteria produce and that are being produced in our gut. Beta-hydroxybutyrate is one of these, and it's very similar to short fatty acids and some very similar activities. Now, ketogenic diet seems to be very good at losing weight, seems to have some effect in epilepsy. It's been investigated in Parkinson's, but it also has side effects. So raised LDL cholesterol and heart disease risk, damage to the kidneys long term. So to get the same effect, I think probably increasing the prebiotic or more fermentable fibers that Rochelle was talking about and stimulating your butyrate might be a more sensible way to go than going onto a ketogenic diet in the long term. Short term is to work fairly well. Yeah.
Rochelle, any thoughts on that?
Yeah, I mean, in terms of the ketogenic diet, I definitely think we need more research. The studies have been fairly small, and like we don't know the mechanism fully yet. I mean, the question is, does it help the levodopa to absorb better, and that's why people, do better in terms of ketogenic, for example. And obviously, cutting out the sort of the whole grains in the diet, the fiber can be sort of less in that diet, and the weight loss is an issue. And we know that weight loss is a bad predictor for outcome in Parkinson's, So what I would say is, if you're planning to do it, it's an individual choice, is to do it under the guidance of a dietitian. And also you can do modified versions of ketogenic that aren't as, as aggressive. And definitely this is an area that I'm going to be watching with an interesting eye, but I think I'd be trying other options first. As Kieran said, from a long-term point of view, it could end up, being more negative.
Thank you. Rick and then Kieran. Sorry. Go, Rick.
Yeah, just very briefly on this, I've tried to sustain a ketogenic diet and found it almost impossible. And so again, from my perspective, it's worth reflecting on what other options are available, because it's quite a difficult regime, particularly if you're socializing. Yeah.
Yeah, I think I'd definitely agree with that, and I think it depends really what we mean by ketogenic diet, because at bottom line, the idea is to reduce carbohydrate intake, and we do that traditionally by boosting fat in the diet. But maybe there's another way we could go about it in reducing refined carbohydrate, keeping a more dietary fiber based, getting rid of the sugars, and increasing whole food intake. And in the end, you're getting much closer to what a Mediterranean diet is. Because the Mediterranean diet is probably the most important thing we should be looking at is the low sugar intake, low sweets. We always talk about the constituents, the red wine and the olives and those kind of, they're romantic notions of what the Mediterranean diet is. But when we look at a chemical view, it's very low in sugars. And definitely in processed foods with, the sweet cakes and things like that. It's not the Italian cuisine that we're used to. It's not tiramisu. It's, it's beans and pulses, as Rochelle said, it's fruit and vegetables, it's fish, it's low intake of meat, low and as in very little or no processed, process is wrong the word, but energy dense sweet foods, cakes, etc.
Yeah.
And that's the profile that is getting much more towards a kind of a low energy dense diet that would result in a lot of butyrate, beta hydroxybutyrate, but without the trouble you have with a high fat intake, both in terms of disease risk and keeping it up. Very difficult to the ketogenic diet long term. The traditional one with fat replacing the sugary carbohydrates.
Thank you. I think that's a strong message. So I'm going to have a question for Pierre. This is maybe a two-part question, and maybe Rochelle can answer the second part. Are there any notable differences for young onset Parkinson's in terms of triggers? Is young onset more common to be gut or nose? And then the second part of this person's question, Ed Fitzgerald, is there any advice on diet management to slow progression? I think that's what everyone wants to know on the call as well. So what about a young onset, Pierre? Any differences?
Right. Okay. Thank you for that question. Yeah. Young onset PD, it depends how young you mean, but to a certain extent, young onset PD is more brain first, whereas body first disease or gut first patients tend to be slightly older. So yeah, and so about the triggers, well, as we haven't discussed triggers of nose first disease, and we don't know, but it could be the microbiome we have in the nose could be involved. It could also be like infections. Perhaps it could even be very common infections like the common cold that we all have all the time. But if you're unlucky and perhaps have the wrong genes, so to speak, that might actually be a trigger of a nose first Parkinson's disease. That's completely hypothetical, but that's some of the things we are studying at the moment. I'll let Rochelle take over.
So what was the second part of the question again? It was
Can
anything you can do to slow progression.
Parkinson's by the diet?
Well, certainly the research again is showing that Mediterranean style diet and healthy eating sort of generally is associated with a lower risk of developing Parkinson's. So I don't think that's going to disappear once you have Parkinson's, and there is a couple of studies that are showing that potentially the Mediterranean diet helps to slow progression. And I suppose from my own experience of, looking at the literature, looking at the research, and also listening to people with Parkinson's with regard to their diets, there's so many things that are, people aren't, like, we did a survey we did a focus group, we did a survey of people with Parkinson's, and we sort of ranked them against the Mediterranean diet score, and they were lower than average in terms of, good Mediterranean diet score. So I think a lot of people, whether they're young or older onset, can do a lot potentially to improve the symptoms. My also theory is I think a lot of younger people are getting accelerated up on their medication dose before actually dealing with underlying issues in terms of constipation, in terms of SIBO, in terms of their diet, and they're not getting access to neurologists, so they're maybe taking more levodopa than is necessary, and this could be feeding in to their gut. We know that some of the bacteria actually eats the levodopa in the gut, and so that reduces their uptake, or people are. I've known some young women who basically have had to manually evacuate their bowel because they've so bad constipation. Like, that should not be happening. That is due to not getting access to care to actually help. So if you're constipated and the diet, a healthy diet's not doing it, you need to be on a laxative to really resolve that issue and potentially stay on one, or you can reduce it down once you get on top of that. So there's many things that I think people are not getting access to that would help reduce or manage their symptoms and potentially slow progression, because they're not been ramped up in their medication too fast. That's my own theory on it. And I suppose just in terms of the young onset, Claire is saying it's brain or gut first. I have celiac disease myself. I also my celiac disease was triggered after my first pregnancy. My Parkinson's was triggered after my second pregnancy, and I have a big interest in this area in terms of sex differences between men and women with Parkinson's. And I definitely think, back to your point, Per, that there's like a trigger. So I don't know whether the celiac is linked to the Parkinson's and the pregnancy hormones, because we know with pregnancy that often women develop other autoimmune conditions like hypothyroidism subsequent to a pregnancy. So, what is the combination that maybe sets off in younger people? And just the other thing as well, from a sex point of view, is that gastroparesis is 3 times higher in women than it is men. So for women, it's something we should be looking out for. And I say people should be asked about the sort of surveys around gastroparesis in the clinics to pick up these things, or around constipation to get on top of these things. Sorry.
That was excellent. No, I really enjoyed it. So I'm going to come to you again for an anonymous question. I would like to get an assessment for my diet to see what changes I can do to improve my Parkinson's symptoms. Would you recommend a dietitian, a neurologist, a PD nurse, or someone else?
Okay, well, unfortunately, neurologists are not, as many consultants are not trained in nutrition. Nurses aren't trained in nutrition at baseline. There are some nutrition nurses that you can find, but they're fairly thin on the ground. So a registered dietitian is someone who's trained, clinically, in different conditions to understand. So now, unfortunately, we don't have enough dietitians trained in Parkinson's, but they are trained enough to be able to help people, in terms of their things like gastroparesis and constipation, etc., and the microbiome and that. We know we actually just published a paper just today, actually sort of raising the issue that, 90% of people with Parkinson's don't get access to a dietitian, and it is a missing part of the multidisciplinary team. And also, I do firmly feel it's a reason why nutrition research is not getting as much, because you need those experts like Kieran working in the area of nutrition and who really can help drive it forward, because I think there's so many answers in diet and in nutrition. So what I would say is, ask your GP to refer you to a community dietitian, ask your neurologist to refer you to a dietitian in the hospital. You don't get if you don't ask. So you just have to keep pushing, and eventually it means the service will have to be found if so that's what I would say.
Excellent. So dietitian is the answer. Clearly dietitian, and ideally someone who's trained in Parkinson's, but they're thin on the ground, as you say. But just any dietitian is such an important part of the Parkinson's journey.
Just to say, it's a bit of a plug, but I'll put it in the chat. But I've put two diet booklets on my website, mymovesmatter.com. So it kind of gives a bit of summary of some of the information that's here, because I know people keep asking for it. So I've just done a few little booklets to help.
Yeah, that's excellent. Yeah. So Kieran, just to go back to something you said earlier, someone is asking, should we avoid recommending probiotics like Yakult for those with PD? It's the same bacteria that you were describing is elevated in PD. So what is your recommendation on probiotics and these these high probiotic drinks?
I think honestly we don't know at the minute. The evidence wouldn't be that strong, but the complication about the bifidobacteria, for me, it's really down to the diet and the sugar intake. And I'd more encourage somebody to take a probiotic, which would actually, stimulate your own bifidobacteria, but it also stimulates butyrate and increases the absorption of L-dopa. So fiber is a very, prebiotics are fiber. So fiber is a very important aspect of this. So I wouldn't be against the probiotics because they can improve dysbiosis. But I think the evidence is weak at the moment that it would have a beneficial effect. I think we need to do more research.
Good, thank you. Rochelle?
Yeah, just coming in that, I was at the Movement Disorder Society Congress in Copenhagen, and at the King's College London presented their work on the SIMprove, and it was compelling that it definitely improved constipation. But I suppose that's the thing, is that if it's improving constipation, is that why the symptoms are improving? Because then the medication is absorbed more. But they do think that there was changes in symptoms due to the microbiome being changed. But I think that needs to be published more, or it has to be teased out more. There's also a study that was done in King's College London with a team called Sylvia Dobbs and her husband, looking at particular types of laxatives. And again, the laxatives actually showed an improvement in rigidity year on year of taking the particular laxative. And again, they don't know if it's to do with the constipation being improved, but they think it might have been that it was altering the microbiome. But again, as Kieran says, I think there's lots of huge potential, but we need more. And my concern would be taking probiotics off the shelf that we don't know. We know a lot of probiotics actually, when they're tested, they don't actually have the probiotics that they say that they have in them, or they don't have them to the levels that they're supposed to. And also, so the one that I suppose SIMprove is the one that probably has the most research to date that is out on the market, but it's not cheap. I think it's about €100 a month. And certainly, some neurologists will give it to help the constipation. And some patients I've heard it's worked really well, and others it hasn't worked. So again, it's an individual thing. But I think you need, before you take any probiotics, you need to talk to your neurologist and let them know what you're doing and keep an eye on it.
Yeah, great, thank you. I'm going to move to another question that I think is quite hot, is about pesticides. We talked about food affecting the microbiome, but does exposure to pesticides disrupt the microbiome, and could this be a reason for the association between pesticides and Parkinson's? I'm not sure who might be best to answer that question. Any volunteers?
Well, maybe I can just say there are probably more direct effects pesticides could have than changing the microbiota. So although they might change the microbiota, I don't think that would be the main danger there. Another important aspect of that is the concentrations we find in our food are such a low level that it's unlikely to trigger the toxicological outcomes, damage to human cells. That's on the other hand, people living in areas where they use a lot of pesticides, that's a very different thing, because your exposure to pesticides in an area that cultivates apples or small fruit, for example, could be much higher than actually what you intake with food. So the pesticide story might not be about food intake, it might be more about environmental contamination.
Yeah, and they're well known to affect mitochondrial function directly. So that's a really good point. So this is I think a good question as well. And unfortunately, we don't have any U.S. people on the panel, but especially if you're US based, where you can get access to a lot of different tests, would you recommend any microbiome tests to look at I guess the constitution of the microbiome? And the second question is about blood tests. Is there anything in the blood that could be measured that can give you an indication of the microbiome state? Rochelle.
Well, I just got to come in terms again as the World Parkinson's Congress, and there was a researcher whose name I forget, but in Australia, and they're doing a lot of work at in the microbiome, and really the tests I don't think are at the level that are going to give answers for he said in terms of as a person with Parkinson's, they're really more on a research basis. So that was what he said to me. So I don't know whether Kieran or Per might have a view on that.
Yeah, I think that's exactly where we're at. Plus, I think a lot of emphasis has gone on the composition of the gut microbiota, what species are there, because of the revolution we've had in the last 20 years in terms of DNA and our ability to identify these organisms. But what is actually important are the metabolites they produce, and they're in blood, not in the feces. And I think we're still trying to get a handle on which metabolites are related directly to microbiota function and when to measure them, because all of these things appear in our blood when they're produced by the microbiota, but then are washed out of the blood or used up by the body fairly quickly. So then, depending on when you take your blood sample, you could have very different concentrations of these metabolites. And so we have to think about not only what metabolites, but when to measure them. And that's something really only just beginning to look at now.
Great, thank you. Another practical question about what to eat. So someone's asking about fermented foods. Are fermented foods good for you? I hear a lot about them, that they're really good, and also a gluten-free diet. So let's address fermented foods first.
So I suppose in terms of fermented foods, they kind of fall in that prebiotic category, which can be beneficial for the bacteria in the bowels. So an interesting enough one is at the World Parkinson's Congress in Kyoto. You noticed when you went for breakfast that they had little bits of kimchi, and it wasn't like a big jar of it, but they had a little bit of those different fermented foods at meal times. In terms of the gluten-free, unless you're celiac or you've non-celiac gluten sensitivity, you don't necessarily need to go gluten-free. What I would say is that anecdotally, I know quite a lot of people with Parkinson's who have celiac as well. So I think it's very important that, going back to sort of tests that people can do, if you suffer from bowel symptoms like bloating, wind, constipation, diarrhea, if you're unintentionally losing weight, if you're anemic, these are all signs of celiac, as well as, they can actually, be symptoms of constipation or gastroparesis as well. But sometimes it's about trying to narrow down if there are other things going on, that feed into your Parkinson's. And I suppose one thing I would say is, if you've diabetes, if you've celiac disease, if you've inflammatory bowel disease, it's really important that you stick to your diet and you stick to your medication regime, because that's about trying to keep your inflammation under control. So it makes sense to me that if you keep your inflammation of other autoimmune conditions under control, that will help towards keeping your Parkinson's under control, in terms of being maybe part of this inflammatory process. So, but no, you don't have to go gluten-free unless you have a particular issue. And I would definitely get tested if you have a family history of IBD or celiac disease.
Yeah, it's really an important point. I think undiagnosed celiac or slight gluten allergy may be unknown. So then a gluten-free diet will help a lot. Someone has an interesting question, I think, for Pierre here. If someone has brain first Parkinson's or nose first, would working on the gut, working on the diet, would it be that helpful?
Oh, yeah. I mean, honestly, honestly, I have to say we simply don't know. So if I had early brain first Parkinson's disease and I didn't yet have some of the symptoms and the constipation that Michelle talked about and so on, I would definitely try and optimize my diet, as the panelists have just discussed here. I mean, why not? It will be beneficial, certainly, all round. And I mean, there's theoretical reasons to think that it might also actually improve your Parkinson's disease or perhaps slow down some of the symptoms. But there's no hard evidence yet. But I would do that myself.
Yeah, good. I would agree with you as well. Just for we're gonna address one last question about medication and diet. So maybe this won't be about the microbiome, but how can you optimize the medication that you're taking, the levodopa, to match your diet to maximize the effectiveness of your medication? So we touched on it a little bit, but I think Rochelle, can you speak to this?
This is a really important one in terms of so the foods that you eat can affect the absorption of your levodopa across your blood-brain barrier, or the transport. And it's in particular with regard to protein that is in your foods. So eggs, chicken, beef, fish, dairy foods, they all contain protein. And they break down into amino acids, which compete for transport with your levodopa or your dopamine across your brain. So we advise people to generally take their levodopa medication half an hour, maybe to an hour, depends, or an hour to 2 hours after your meals, so that the levodopa has that chance to get to your brain before protein foods might interfere with it. Now there's a caveat to that, just to say that people who suffer from dyskinesias, if you separate, so dyskinesia is often because, and especially the younger onset, dyskinesia often is a side effect because of levodopa absorption. And if you separate your meals from your medication, you increase your levodopa absorption. So that could potentially worsen dyskinesias. So sometimes you need to reduce your levodopa and separate it from your meal timing. Other people who are longer with Parkinson's are taking many medication doses a day. It's very hard to do this timing, like it's a nightmare. So there is what we call a protein redistribution diet, where you put more of your protein in the evening and less protein during the day, and that allows your medication to be absorbed better during the day. And then the evening you might be a bit more off because you're taking all your protein in the evening. But if most people are trying to work during the day, and again, that needs to be done alongside a dietitian, because you can lose weight if you're not making sure that you get enough protein. So that's probably the main thing. And then I suppose the other thing is, in terms of if you have big meals with high fat, high protein meals, it slows your gastric emptying of your stomach. So your tablets end up stuck in your stomach and get degraded by the acid. So it doesn't get to the small intestine, to get to your bloodstream, to get to your brain. So there are a number of things, along that path. I suppose the other thing is in terms of the gut starts in the mouth. So swallowing, the tablet can get stuck in your gullet. So there's a number of things you need to watch out for.
Great. Thank you. Thank you, Rochelle. It's been a whirlwind tour. So I'm just going to mention just a few take-home messages. So I think diet in the microbiome is incredibly important for Parkinson's, whether it's gut first or nose first. I think it's really important to pay attention to. I was really struck that 90% of people with Parkinson's don't have access to a dietitian, and that needs to change. Rochelle has a website, mymovematters.com, where you can download a lot of information about diet that Rochelle's been putting together. In terms of what you should do and eat, I think one of the main messages is low sugar. Ultra processed food should be eliminated. The Mediterranean diet is probably the most safe diet. Gluten-free should be considered if you're celiac, if you have gut problems. So please get tested if you don't know. But if you want to hear more about diet in Parkinson's, I'm going to put a plug for Rochelle Flanagan. She is the Edinburgh Parkinson's lecturer for 2024. On the 17th of September, she's going to be in Edinburgh. The title of her lecture is How Nutrition and Diet Can Help You Live Better with Parkinson's. If you can't make it to Edinburgh, this lecture is also virtual, and it will be recorded, and you can watch the recording afterwards, or you can watch it live. And we have 45 minutes for questions in that lecture. So Rochelle, We'll have the stage September 17th if you want to hear more. And finally, there's a survey that's sent out after this call to all the registered attendees. Please fill it out. It really helps us to improve future webinars. And lastly, I really want to thank our panel, Rochelle, Kieran, Rick, and Pierre for amazing discussion. And I'm sorry we couldn't get to all the questions, but hopefully we can see some of you at Rochelle's lecture. Thank you very much.
Thanks a million.